Good morning, student. Today we will find the inverse Z transform of the given function x of z is equal to z raised to power 3 minus 10 z square minus 4z plus 1. Sorry, plus 4 divided by 2z square minus 2z minus 4. With ROC is given that the magnitude of z is less than 1. And here we can see that the highest power of the numerator polynomial is 3 and the denominator polynomial is 2. That means m is here greater than n. M is here greater than n, and that is not the case. So therefore we have to use the long division methods in order to reduce the power of the numerator polynomials from the denominator polynomials. Okay, so the solution for this is we have to find the poles at by determining the roots of the denominator polynomial. This is the denominator polynomials, and we have to find the roots of this determined denominator polynomials, and roots are nothing but the poles. So poles are at z is equal to -1 and at z is equal to 2. These are found from the denominator polynomial equations. So these poles are there. We have to locate these poles in the z plane. Therefore, location of these poles in the z plane is like this. This is -1 pole and this is a 2 pole, and this is origin, and therefore there is this is the unit circle of radius 1, and this ROC here is less than 1, and therefore this is the given ROC. Okay, this is real part of Z, imaginary part of Z. Okay, so this is the Z plane, we can say, and this is the location of poles and ROCs. This figure is location of poles and ROC. Okay, now we have to convert x of z into the ratio of the polynomials, into a ratio of the polynomials in z raised to power -1. Okay, so we can factoring z cube from the numerator. We have to factoring the z cube from the numerator and the 2z square from the denominator. So if you factoring out z cube from the numerator, then what will be remain in the bracket? That is 1 minus 10z raised to power -1 minus 4z raised to power -2 plus 4z raised to power -3. So this 1 minus z raised to power -1 minus 2z raised to power -2. Okay. So what will be remain here? It will remain half into z, and the rest of the things will be z divided by -2 z raised to power -2 minus z raised to power -1 plus 1. Okay, so this is the after converting x of z into the ratio of the polynomials of z raised to power minus 1. So this factor, the two factors are there. This is first factor and this is another factor. This factor we can incorporate in the latter stage by using the time shift property, and now we'll focus on this factor only. We'll focus on the ratio of the polynomials in the parenthesis, and therefore using the long division method to reduce the numerator polynomial. Okay. Using the long division method to reduce numerator, to reduce order of the numerator polynomial. And therefore we have to use the long division methods. Long division methods is this 4z raised to minus cube minus 4z raised to power minus 2 minus 10z raised to power minus 1 plus 1 minus 2 minus 2z raised to power minus 1 minus z raised to power minus 1 plus 1. Okay, so here we want 4. So if we want 4, we have to multiply it by 2. So 2 to the 4, and here we want z cube. Z cube. So minus 2 is minus 4, and z raised to power minus, actually it is 2 here, z raised to power minus 2. So minus 2 z raised to power minus 2 here, so it will be here minus 2. Okay, so it is z raised to power minus 3 minus plus 2 z raised to power minus 3 sorry, here it should be 1. Okay, z raised to power minus 1. Okay, then we will get here 4 minus plus 4 z raised to power minus cube, and here we have to multiply by minus 2 z raised to power minus 1 to this, so minus plus 2 z raised to power minus 2. Okay, multiplied that by this, so it is minus 2 z raised to power minus 1. So subtract this, will get cancelled. What will remain there? Minus 6 z raised to power minus 2 minus 8 z raised to power minus 1 plus 1. Okay, so here now we require 3. So we require a negative sign. Negative sign is already there. We require 3. So 2 is already there. So it will be 3. 3 into 2 is 6 z raised to power minus 2 plus 2 z raised to power minus 1. No, not 2. It is minus 3. minus 3 minus 3 into z raised to power minus 1 plus 3 okay, so we have to, this will be the this will be the actually 3 multiplied by this is minus sign. Okay, so to subtract these two equations, this will get cancelled. What will be remainder? 5z raised to power minus 1, and here it will be minus 3. No, not minus 3. 2. Okay, so this is a remainder. Now we can solve this long division methods. Now we can write here. We may write the given expression now. 4z raised to power minus cube minus 4z raised to power minus 2 minus 10z raised to power minus 1 plus 1 divided by minus 2z raised to power minus 2 minus z raised to power minus 1 plus 1 is equal to minus 2z raised to power minus 1 plus 3 plus minus 5z raised to power minus 1 minus 2 divided by 1 minus z raised to power minus 1 minus 2 z raised to power minus 2. We have to find the factor of this. So minus 2 z raised to power minus 1 plus 3 plus minus 5 z raised to power minus 1 minus 2, and factor of this denominator polynomial is 1 plus z raised to power minus 1 into 1 minus 2 z raised to power minus 1. So using the partial fraction expansion, we may now have for the second factor a over 1 plus z raised to power minus 1 plus b over 1 minus 2 z raised to power minus 1. Okay, solving a and b. Is 1 plus z raised to power minus 1 into minus 5 z raised to power minus 1 minus 2 divided by the whole factor. This is where to put z square z raised to power minus 1 is equal to 1. So this value is coming minus 5 into 1 z raised to power minus 1. This value should be there. Minus 2, and this is 1 minus 2 into z raised to power minus 1. So this is a 5 minus 2. This is 1 plus 2, 3, 3 is equal to 1. So the u is equal to 1. I have to find the b also. 1 minus 2 z raised to power minus 1 into minus 5 z raised to power minus 1 divided by 1 plus z raised to power minus 1, 1 minus 2 z raised to power minus 1 at z is equal to, sorry, z inverse is equal to 1 by half. So this will cancel here, and the remaining terms will be there. minus 5 into half minus 2 over 1 plus half. So minus 5 by 2 minus 2. This is 3 by 2 minus 5 minus 4 by 2, 3 by 2. And what will remain here now? Minus 9 by 2, 3 by 2, 9 by 2 and 2 by 3. So it is a minus 3 is equal to B. So value of B is minus 3. So we can put these values. So minus 5 z raised to power minus 1 minus 2 divided by 1 plus z raised to power minus 1 minus 2 z raised to power minus 1 is equal to that is 1 upon 1 plus z raised to power minus 1 and minus 3 upon 1 minus 2 z raised to power minus 1. Okay, so this is the solution with ROC, that is a magnitude of z is less than 1. So here ROC has a smaller radius than either pole. Okay. What is the poles here? Poles are S is equal to poles are at z is equal to minus 1 and z is equal to 2. This is minus 1 and this is a 2. And what is the ROC? ROC here is less than 1. ROC here is less than 1, and therefore we can write here as the ROC has a smaller radius than either pole. So the inverse Z transform we can define further. We have found this factor. So this is x of z. This is x of z into half of z into this. So we will give the name to this is W of z. W of z. Okay. So we'll write half of z into W of z, that is x of z. X of z is equal to half into z into W of z. Okay. So what is the W of z we have got here? W of z is minus 2 z raised to power minus 1 plus 3 plus 1 over 1 plus z raised to power minus 1 minus 3 over 1 minus 2 z raised to power minus 1. This value we have got with ROC here, the magnitude of z is less than 1. Okay. So the ROC has the radius, smaller radius than the both the poles, and therefore the inverse Z transform WZ the inverse Z transform of the WZ, that is 2 minus 2 into del raised to power n minus 1 and plus 3 into del of n. Okay, again plus third factor 1 over 1 plus z raised to power minus 1. So what is here? AK is here 1. Here it is less than 1, therefore it is a therefore AK is the minus sign, AK is 1 here. Okay, then dk raised to power n. What is dk? Dk here is 1. Okay, so this minus sign will appear here now. Minus sign will appear here. As this ROC is less than this 1, therefore minus sign will appear here. And this is minus 1 of n into u of minus n minus 1 as per the standard equation, plus this AK is minus 3, so minus minus plus here it is a AK is 3, then dk raised to power 2, dk is here 2, it is 2 raised to power n and u of minus n minus 1. Okay, so this is the inverse Z transform. Of our equation. Okay, so we have got this like this, and finally we have got the factor, that is, so x of z is equal to half into z w of z. So we have found the inverse Z transform of this W of Z, but this factor is remained, that is half into Z. And this may we now apply by using the time shift property. So therefore, by using time shift property to obtain x of n is equal to half into W of n, and now the time shift property W of n plus 1. Okay, and therefore we can write x of n is equal to minus del of n plus 3 into del of n. So this is a 3 by 2 del of n, and this is a, so this is a del of n plus 1. Next is minus half into minus 1 raised to power n plus 1, and this u of minus n minus 2. Next is plus 3 into 2 raised to power n into u of minus n minus 2. So this is inverse Laplace transform of the given function.